Okay, ladies and gentlemen, this one is going to be a really quick overview kind of video about our next unit, Unit 5, which really just consists of one chapter, Chapter 9. We just finished Unit 4, which was all about work and energy. And here we're talking about momentum, and we'll get to collisions. That's going to take us a little while to get to collisions. And the sharper among you are going to say to yourselves, wait. We did Unit 1, we did Unit 2, and then there's 4 and 5. What happened to Unit 3? Don't worry about the unit numbering, actually. The unit structure that this course is comprised of stems from a list of topics that's a suggested order. And those topics in that suggested order don't quite occur in a matching order in our textbook. So I've rearranged the units to better follow the sequence of chapters in our book, and there's some good reason for that, because the way the chapters are written, there's some sequential nature to it that crops up here and there, where one chapter is going to rely on some previous knowledge from other chapters. Anyway, none of that is terribly important. What matters here is here in this overview, I just want to show you real briefly, super fast, what we will be looking at. There's an idea of linear momentum, and this is discussed in 9-1. And there will be a definition of linear momentum. We will look at an example, and particularly why that. What's important about linear momentum, not just how to calculate it and the mathematical relationships, but the fact that momentum is a vector, and its direction matters and has great significance for what we're going to be working on later in this unit. We're also going to look at how momentum is related to Newton's second law. That's going to be 9-2. Turns out Newton's second law, the way we've looked at it so far, is not the original form in which Newton described the relationship, and so we'll see that as we get into it. We're also going to take a look at this idea of what's called impulse. This will be in section 9-3. Oh, by the way, these might not necessarily be separate videos, because a number of these ideas flow naturally together and may not take us very long to cover, so we'll be combining a little bit. But this idea of this thing called impulse, and there's a theorem, much like the work-energy theorem, that's going to be called the momentum-impulse theorem. And we'll see some similarities between the two relationships, work and energy, and here, impulse and momentum. We're going to also look at how momentum is a conserved quantity. Conservation of momentum, that's going to be 9-4 in the textbook. So there's certain conditions that will exist that will lead to this momentum being conserved, and we will definitely examine those. And then finally, we're going to get to collisions. Now, collisions they fall into two broad categories. We call them inelastic collisions. That's dealt with in 9-5, and also elastic collisions. And that's dealt with in 9-6. There is one more section in this chapter, 9-7, and it deals with a topic of changing momentum and lots of examples, but in particular where more than just one thing leading to momentum is changing. It's a more complicated yet more realistic approach. We may be just leaving that one alone. I'm kind of up in the air at the moment regarding that. But this is the bulk of it. And in particular, these last three sections, conservation of momentum, inelastic collisions, and elastic collisions, are of great importance to us in our studies of physics. So I wanted to give you this brief overview and keep these sort of relationships, these general organizational relationships in mind. Thank you for watching. I'll see you next time.